What's done for having what has he done for head of spirit?
When we look at rotational motion, we have to consider a rotational force that is applied to the object. This force is called torque, or the force that causes an object to rotate. The location of this force along the object affects the speed and direction of rotation. A higher rotational torque indicates a higher rotational speed, while a lower rotational torque indicates a lower speed. Now you might ask, how do we determine the sign of torque? To do this, we use the right-hand rule. So to do this, first you want to hold out your right hand and then curl your fingers in the direction of rotation. So in this scenario, you can see that there's an upward force being applied to the right side of the object. So you can visualize that the object will rotate in this direction. So now hold out your right hand and curl your fingers in the direction of rotation. So it will curl like this. And then you want to point your thumb out and make it straighten your thumb. And since my thumb is pointing outwards, this will mean torque has a positive sign. If my thumb was pointing inwards, it would be a negative sign. Now that we understand torque conceptually, we also need to understand it mathematically. To put it simply, torque is the applied force times the distance between the applied force and the axis of rotation times the angle that the force is applied. Now that we have this equation, what angle do you think would result in the highest torque? I'll give you a few seconds to think of an answer. If you said 90 degrees, that's correct. Since sine of 90 degrees is equal to 1, that would result in the highest torque, and any other angle would be a lower torque. Now let's go look at a sample problem. In this problem, there is a block applying 100 newtons of force on the right side of this object, 0.4 meters away from the axis of rotation. Now that we have this equation, I'll give you a few seconds to pause the video and attempt this problem by yourself. Okay, now that you have hopefully solved the problem, I'll also go over the solution. So first, we see the equation with force is torque is equal to force times the radius times the angle. So torque is equal to the force, 100 newtons, times the radius, 0.4 meters, times the angle. And since the block is directly on the object, angle is 90 degrees, so we sine of 90. And sine of 90 equals 1, so it's not really factored into the equation here. So we would get torque is equal to 100 times 0.4, which is 40, times sine of 90, which is 1. So torque would equal to 40 Newton meters, and that is the unit for torque. Now we also have to consider the sign of torque. So we can go back to the right hand rule. If you hold your hand out and curl your fingers in the direction of rotation, since the object is on this side, the object will rotate in this direction. So you want to curl your fingers like this and then point your thumb out. Since my thumb is pointing towards the whiteboard, that means that this object is rotating, the torque for this object is negative, which means the torque will be negative 40 Newton meters. And That is an example problem how to solve torque. Now that we understand how an object rotates, we also need to understand the forces preventing rotation. This is called the moment of inertia, or an object's resistance to change in angular acceleration. This force is dependent on the mass of the object and the distribution of this mass along the axis of rotation. The moment of inertia of a point particle is mr squared, with m being the mass of the object and r being the radius of the object. However, the moment of inertia of an object varies depending on the shape of the object. For example, a cylinder has a moment of inertia of 1/2 mr squared, while a hoop has a moment of inertia of mr squared. This means that whenever you're looking at the moment of inertia of an object, you need to factor in the shape of the object. Now let's move on to an example problem on how to solve the moment of inertia.
In this example problem, we have a 8 kilogram hoop with a radius of 4 meters. If you think that's a hoop, the moment of inertia of a hoop, that would be inertia equals mass times radius squared. Now, looking at the picture, we just want to plug in the values. Inertia equals mass, which is 8 kilograms, 8 times radius squared, which is 4 meters, 4 squared. And this equals to 8 times 16, which is just 128 or 120 kilogram times meter squared for this question.
I hope that all of you have a better understanding of rotation of motion now. And remember, you can do great things.